Okay, so we have talked about the importance of algebra as a background for calculus. Usually, for students who take calculus, calculus is not a problem. It's the algebra that would give you a problem if you have one. And so we're reviewing factoring. We already said on this first one that you would factor out the 8 as your GCF, and then x minus 10 would be in parentheses, backwards distributed property. Now, on the next one, because you guys were working on this, what did you notice you could do first? Factor out a 2. And after you factor out the 2, what did you have in parentheses? Well, I would actually need to factor out more than the 2, wouldn't I? Because if I look at each of these terms, they also all have an x. So 2x needs to be my common factor. And that would leave in the parentheses the x squared plus 10x. Oh, sorry, plus 5x. Thank you. Let me erase that real quick. Okay, so plus 5x, and then what's going to be at the end? Minus 1. Because remember, if I use distributed property, when I multiply everything back through, it ought to equal what I started with. So since 2x was my GCF, I just need a minus 1 there on the end. Okay, now this next one is a little different because I don't see a GCF in every term. Instead, this one is one that you would use a method called grouping for factoring. And it means we're going to look a pair at a time and see if we can recognize a common factor for each pair. So if I look at these first two terms, 20 minus 5m, what would be my common factor for those two terms? I could factor out a 5, and then what would I have in the parentheses? So I'm going to recopy this over here so I have a little bit more room to work with. All right, the way that I would explain this when I teach this in my intermediate algebra classes to developmental students is after you take the first pair, you want to copy the sign that's in the middle. So I'm going to bring down the minus sign, and now I'm going to look for the GCF in the last pair. What would be the common factor between 12n and 3mn? Yes, I'm going to factor out a 3n. And when I do that, then what would go inside the parentheses? Well, I'd have a 4 because the negative 3n times 4 is a negative 12n. Now here's where you got to be careful with signs. A negative times what sign gives me back a positive? A negative times a negative. So that needs to be 4 minus m in the parentheses. Okay, you guys following me? All right. And now what I'm doing is I'm looking for a new common factor because think about it for a minute. I have a pair being multiplied together. Something times a parentheses minus something times a parentheses. If I think of this as two factors separated by a minus sign, I have a common factor again. What my goal is to see if I can get the parentheses to match. And they do match. That becomes my new common factor. So 4 minus m is the GCF, and then in parentheses, I put the common factors that I pulled out in the line above. And that would be 5 minus 3n. This is the factored form of 20 minus 5m minus 12n plus 3mn. That's called factoring by grouping. How many of you have done something like that before? Okay, so if it's been a little while, I'm just reminding you that's how you can factor. Now, when you get to number 4 on this sheet, it's a trinomial, 3 terms. It's quadratic because my variable has a 2 as an exponent on it, but I do not see a common factor anywhere. How many of you say, I know how to factor this? Do I see hands? Okay. A few. How many of you say, I probably need a reminder? So let me kind of talk you through, in case it's been a while since you factored, what you need to be able to do with something like this. There is more than one way to factor trinomials. If you happen to be kind of a, I like playing with numbers type of person, then most likely you have factored by opening up two sets of parentheses and you do backwards FOIL. And you kind of guess and check with numbers using FOIL to make sure that after you use FOIL you get what you started with. And that is perfectly okay to do that. In fact, that used to be the only way we taught people how to factor. And as I said, if you are a numbers person and you like playing with numbers, you're probably going to do that because unless the numbers are really large, it's most likely going to be faster for you. But on the other hand, if that's always seemed like, I have no idea how people do this, it's like they just pull things out of the air and say this is the answer, and that doesn't make sense to me. I'm going to show you how you can factor by grouping, which is what we just did, so that you have a systematic way you could factor that would work every time. Now what's different here from what we did a minute ago is on number 3, how many terms did we start with? This one right here, how many terms are in that problem? 4. I only have 3 terms in my problem. I have to take something that's 3 terms, a trinomial, turn it into 4 terms before I can use grouping. And this is why you need this little tool called the AC method if you don't know how else to factor trinomials, because it will give you the ability to turn it from 3 terms into 4. So if it's been a while since you've seen it, or maybe you've never understood how to factor, let me show you how you could do that. The reason it's called the AC method is because ax squared plus bx plus c is considered standard form for a trinomial that's quadratic, okay? And the a is the coefficient or the number in front of the x squared, b is the number in front of the x, c is the constant at the end. So with the AC method, if you multiply a times c, that means we're taking the number in front of the x squared times the constant on the end. Looking at the problem that we have on number 4, that would be 8 times the number at the end is a positive 5. And 8 times 5 is 40. We would need a pair of numbers that will multiply to give us 40, okay? But there's a second part to this. We also have to look at what the b value is. And the b value is what's in front of the x. Now, the sign that's in front of a number stays with a number. So what is the coefficient in front of the x term? Negative 13. That means our pair of numbers also must add to give us negative 13. So here's the goal. Got to get a pair of numbers, multiplies to give me positive 40, adds to give me negative 13. Any idea what that could possibly be? There you go. The only way I multiply and get a positive, signs have to be the same. Now, here's something else you need to make sure you haven't forgotten. Do you remember all your sign rules as far as how to multiply positives and negatives, how to add positives and negatives? Because you have to know sign rules really well, or that's going to trip you up. So let me just remind you here. If I multiply 2 numbers and I get a positive, it tells me signs are the same. They're either both positive or both negative. When I look at the sign for the b value, that's going to tell me which pair I need. Since they're going to add up to be a negative, is it possible for a positive plus a positive to give me a negative? No, has to be a negative plus a negative, right? So that tells me I need 2 negative numbers, and the right pair of numbers that would add up to give me a negative 13 multiplied to give me 40 is what? That's it, negative 8 and negative 5. Now, this pair that I just found is not what goes in the parentheses for factored form. Instead, it's the pair I need to rewrite the middle term, because I'm taking these 3 terms, turning them into 4 terms. So that means I'm going to replace the negative 13t in the middle with a minus 8t minus 5t. Nothing else about this is going to change. All I did was change a trinomial into 4 terms. Now, double check, is this equivalent to what I started with? Because a negative 8t plus a negative 5t is a negative 13t. I've just rewritten it. But I can't randomly choose, like I couldn't put in negative 10t and minus 3t. Yes, that adds up to be a negative 13t, but it's not going to help me out on the factoring in the next step. So using this AC method, especially if the numbers get kind of large, or there are numbers that have multiple ways of factoring them, you might want to do this quickly to double check, because this will tell you if it's possible for it to factor. If it's not possible to get a pair of numbers that multiplies to match what A times C is and would add up to give you what the B value is, that right there tells you it's prime, it won't factor. So now that we've replaced it, we're going to do factoring by grouping. You look at the first pair, what's the GCF? 8t squared minus 8t, I'm going to pull out what is a common factor? 8t. And then in parentheses, I'll have t minus 1. Good job. Remember, match the sign that's in the middle. So that means I need to bring down the negative sign. And now when I look for the GCF in the last pair, it's got to be what? 5. Now carefully tell me what goes in the parentheses. Good, because negative 5 times t is negative 5t. Negative 5 times negative 1 is how I get back a positive 5. And since my parentheses match, that tells me that's my new common factor, the t minus 1. The other parentheses has 8t minus 5 in it. Okay, if I were to ask you guys, how comfortable are you with factoring trinomials? Give me a little thumb signal, either a thumbs up, thumbs down, or might probably need to work on this a bit more. Okay, the next one is probably one that you look at that number 4 is actually harder to factor than number 5, because as long as that a value is 1, if it's just an x squared for the first term, or in this case an r squared, then there's a little shortcut you can use. Do you know how to factor r squared plus 18r plus 72? All I'm looking for is what would I multiply to get a times c? Well, 1 times 72 is 72. So what can I multiply to get 72? Add to get 18. I'm going to have to think for a minute. Well, this is where, if you're not sure, you might want to use a calculator. And you can do 72 divided by something until you figure out what the right pair is. Now, if you're like me, when I ask you what would you multiply to get 72, what do you think? Anything in particular come to mind?
6.
Okay, you played with it a little bit, and you came up with 6 would go into 72 how many times?
12.
All right, 6 times 12 is 72. What's 6 plus 12? 18. When you get, and everything was positive here, so I need a positive 6 and a positive 12. If I can come up with the right pair that multiplies to give me a times c, adds to give me b, and my a value is a 1, that pair I've come up with is what actually shows up in the parentheses. This factors into r plus 6 times r plus 12. Now, if that had been a 17r in the middle instead of an 18r, would that have been easier to factor? Because what would you think of? What else could you multiply to get 72, but it would add up to give you 17? 9 times 8. All right, so you got to be careful and make sure you come up with the right pair, because it's got to add up exactly to give you the b value in addition to multiplying to give you the a times c. Now, number 6 is a little different because I don't see 3, there's not 4 terms, there's not 3 terms, there's only 2 terms. And I'm going to take you back up to the top of the page for a minute just to remind you about steps for factoring. We've already said you look first for a GCF, but what we have on this next one, the only common factor we have is 1. If your GCF is 1, you don't have to write that down. In fact, you shouldn't write that down. You're only going to factor out something if the GCF is greater than 1. We have actually been practicing what happens when we have 3 terms, which is this 2b, and going through the steps of grouping. This is the first time we've seen one that just had 2 terms that didn't have a GCF other than 1. And what we're going to check for is to see if we might have a difference of squares. There are 3 questions you ask yourself, and that will tell you if you've got a difference of squares. Is first term a perfect square? So if I scroll down and ask you again on number 6, is the first term a perfect square? The answer is yes. Is the last term a perfect square? Yes, because the square root of 1 is 1. But the third question is the sign in the middle subtraction? And your answer is no. If you get a no to any one of those 3 questions, your answer is that this is prime. It will not factor. Or you can put NF for not factorable. Now, if that had been a subtraction sign in the middle, we would have gotten a yes and we would have been able to factor it. Let's look at number 7 and let's make sure we can factor this one. 36x squared minus y squared. Is the first term a perfect square? 36x squared. Yes, because if I ask myself what's square root of 36, it's 6. And as long as I have an even exponent on a variable, that's a perfect square. Is the last term a perfect square? Yes, square root of y squared is going to be y. The sign in the middle is subtraction. I just got a yes to all 3. So what that tells me is this is a difference of squares. And here's how you factor it. You automatically set up 2 parentheses. It's going to be a backwards FOIL kind of thing. But what happens is the square root of the first term goes in the front of each parentheses. So what's the square root of 36x squared? 6x. So I have a 6x in the first of each parentheses. The square root of the second term goes at the end of each parentheses. What's the square root of y squared? Y. So y at the end, and then one parentheses gets a plus, one parentheses gets a minus. It doesn't matter the order that you write them in. And how could we check to be sure we really factored this right? Multiply them back together using FOIL. Does everybody remember how to do FOIL? Just in case you have forgotten, FOIL is first, outer, inner, last. It's just a way to organize yourself with distributive property. You might also want to use something like this box to help you organize. I just made a box that's a 2 by 2, and the reason I did that is because I have 2 terms in 2 parentheses. So that means I want 2 rows, 2 columns. And I'm going to take one parenthesis and I'm going to write each term across the top of each column. The other parentheses will go beside each row. So 6x goes to the left of the top left box. And then remember, the sign in front of a number stays with a number. So I'm going to put a negative y at the bottom. I would then multiply these terms together and write the answer in the box where the row and the column intersect. So 6x times 6x goes in this top left box. That's 36x squared. 6x times positive y is a positive 6xy. 6x times a negative y is a negative 6xy. And negative y times positive y is what? A negative times a positive is a what sign? A negative times a positive is a negative, and y times y is y squared. And why the reason this is called a difference of squares is because with that minus sign in the middle, if I multiply these factors back together like I'm doing right now, what happens to these middle terms? They cancel out, and then I'm only left with the perfect square in the front, the perfect square in the end, and a subtraction sign between them. So that is how that factors. Okay, so far we're okay on reviewing factoring, correct? All right. There's one more we could do, but since we've covered it, I think for right now, let's just skip over that and let's review some exponent rules. I have a number of rules that I need to have in my toolkit to be able to be successful in this course. So let's just make sure we haven't forgotten these. And I know sometimes when we see all letters written out in a math class. That's a little freaky. So let me just kind of also give you some examples that involve numbers to make sure this makes sense. The product rule says this. If I am multiplying and my base is the same, so if I had something like x cubed times x squared, what would that equal? X to the what power? X to the 5th power. Now, in case it's been a while and you're thinking, okay, I don't really remember why that works, what does an exponent actually mean?
How many times you're going to multiply that number?
Perfect. How many times you're multiplying that base times itself. So x cubed means I have 1, 2, 3 x's being multiplied together. If I'm just going to write out what this means, that's what it is. The x squared means I have 2 x's being multiplied together. Since an exponent is simply a shortcut for how many times something's being multiplied times itself, count those up. There are 5 x's. So the shortcut is, if the bases are the same and I'm multiplying, I add up the exponents. Now, a quick reminder, this usually trips people up. If I asked you what something raised to the 0 power is, you got to be careful. It's not 0, all right? We're going to come back and talk about this in just a second, but I kind of want to hit these in a little different order. These are not written in the order we typically learn them. So let's come back to that 0 exponent in a minute, because I want to make sure we also cover the quotient rule and the power rule first. So the quotient rule tells us that if we had something like this, x to the 4th, and you were to divide that by x to the 1st, okay? And when it's to the 1st, you normally don't see a 1 if there is an exponent. It's understood to be 1. Do you know what that would mean? That has to equal what? It would be x to the 3rd power. And the reason is, if I have 4 of these x's on top and 1 x on the bottom, as long as I am dividing and I have a common factor between something on top and something on bottom, I can cancel out or reduce down. So my shortcut is, if I have bases the same and I'm dividing, all I have to do is subtract exponents. That's why this is going to equal x to the 3rd. Okay? Now, power rule is when I have an exponent on an exponent. So, for example, if I had x to the 3rd, and I ask you to square that, what is that going to be? What do you think? X to the what? It's going to be x to the 6th. Now, let me show you why. X to the 3rd, we said, means 3 of these x's being multiplied together. And if I'm squaring something, it tells me I'm multiplying it times itself. So that would mean that I'd have another parentheses with 3 x's in it. If I count those up, that's how many x's? X to the 6th. So that's what this power rule is reminding us we're supposed to do, is raise a power to a power. And you would get, by multiplying the exponents together, x to the 6th. And let me scoot this over so you can see it. Okay? All right, so far so good? Now, I want to use the quotient rule to explain to you about this, something being raised to the 0 power. Okay, so now that we know the quotient rule, let me ask you what we could do with something like x to the 3rd over x to the 3rd. Can I use the quotient rule here, which tells me as long as the base is the same, I can subtract exponents? Sure can. That would mean it has to equal x to the 3 minus 3 power, which is x to the 0 power. Now, back up and think about what else we know. If I have an x to the 3rd on top and an x to the 3rd on bottom, What is anything divided by itself? 1. That's why anything raised to the 0 power equals 1, because I could use the quotient rule to show the reason that's got a 0 as an exponent is it had to be equivalent to something raised to a power over the same power, okay? So don't forget that. Anything to the 0 power will equal 1. Now, here's the last thing we'll cover, and that's going to be, well, I shouldn't say the last thing. There's actually 2 more things we're going to cover. The negative exponents, what they mean, and how we work with them, and then we'll talk about fractional exponents. Now, a negative exponent has nothing, absolutely nothing to do with the sign of the answer. Instead, it merely tells us about location. And I want you to think about this for a minute. We looked at x to the 4th over x to the 1st a minute ago. Follow me over here for a second. I'm going to need a little more space. Okay. And I want us to do this the other way around. Suppose we had an x to the 1st on top over an x to the 4th on bottom. Okay? Now, if I write out what it means, I've got one x on top. How many on bottom? 1, 2, 3, 4. Which, since I already know, sorry, that's a little messy there. Since I already know if I have a common factor on top and bottom, I could cancel those out. This is going to cancel out with one of these. Now, be very careful. If I cancel out the x on top, what's left on top? Oh, be careful. What is that? Yeah, everything has a common factor of 1. We just don't write it down. The coefficient in front of that x is a 1. So if I cancel out the x on top, there's still 1 up there. And what would I have on bottom? And go ahead and put it back in exponent form. X to the 3rd. Now, that's if I write out what it means. All right, so I can follow what's going on. But use your quotient rule for a minute. If I have a 1 on top and a 4 on bottom, remember how we said you can subtract the exponents? And if you subtract the exponent on top minus the exponent on bottom, that gives you what? X to the negative 3. Now, wouldn't it be true that these two have to mean the same thing? Sure do. So what I want you to keep straight is, first of all, anytime you see a negative exponent, it has absolutely nothing to do with the sign of the answer. There's not a negative in front of this x cubed. But if I want to write it with a negative exponent, it doesn't look like a fraction. If I want to write it with a positive exponent, it will look like a fraction. Okay? So that's all you have to do. In fact, here's a good way to think about it, and it's written right here where it says negative to positive rules. If I see something with a negative exponent, okay, let me kind of write this out in a way that hopefully, oops, I don't want to do that. Let me do this, sorry. If I write this out in a way that hopefully would make sense, maybe if we had a 3 on top over an x on bottom, and this whole thing was raised to the negative 2 power, if I wanted to write this with positive exponents, all I have to do is flip the fraction, because the negative tells me everything's got to change location. What's on top is going to go to the bottom, what's on bottom is going to go to the top, and then my exponent would be positive. So that's going to be the same thing as x on top, 3 on bottom, raised to the positive 2 power. Okay? If it doesn't look like a fraction, sort of like we had up here, the x to the negative 3, think of that as x over 1. And then if I flip it, doesn't it turn into 1 over x to the positive 3? Because it's really 1 to the 3rd on top, but it doesn't matter what my exponent is on a 1, it still is just going to be a 1. And that would give me the ability then to take things from negative exponents back to positive if I want to. And I need to make sure I understand what negative exponents mean. So give me a quick signal. Are we still at a thumbs up? Awesome. Okay, so here's the last thing, and I typically find that this ends up being something for a lot of students that either you've not been shown this before or you haven't used it enough that you feel comfortable with it. And it's the idea that fractional exponents can be rewritten in radical form. So the way that the rule is written out probably